it's absolutely going to be a shift in thinking about data, how to organize it correctly, how to leverage it properly, how to use it, the algorithms, and it's all on the table for change today.
I'm joined today by Jeffrey Can. He is a published author, podcaster, inspiring professional speaker. His passion is the oil and gas industry, essential to our modern industrial society, and it's imperative to exploit digital innovations as we slowly transition to new fuels. He has worked around the world, including Canada, US, Korea, Japan, Hong Kong, China, Australia, and the Caribbean over a 35-year career. He teaches a seminar on digital oil and gas, produces a weekly article and podcast on digital issues and energy, and has published his first book, Bits, Bytes, and Barrels, The Digital Transformation of Oil and Gas. Welcome, Jeffrey. It's really nice to talk to you.
Oh, it's a pleasure to be here. Thank you for taking the time to speak with me today.
Yeah, no problem. And maybe you could tell me what inspired you and a little bit of the background as to what eventually brought you to be a published author.
I probably have an internal drive to get ideas out of the way, sort of crowding out space in my brain. But the idea behind the book came about because I had, over the course of probably 18 months, had written 60, 70 different articles. And the original design of the article series was always that it could eventually turn into or be reformatted as a book. Why I wrote it is probably the more interesting question. I see the demand for digital innovation in oil and gas to be lagging behind the supply. In other words, the supply is strong. There's lots of innovators with good ideas, and the technology changes out there are very capable and powerful. But the demand side is weak. And when that happens, of course, the price is too low. But also as a society, we absolutely need, whether we like it or not, we are going to be consuming fossil fuels for quite some time while we sort our way through energy transition. And we need this industry to be cleaner, more efficient, lower cost, less impact on the environment. And without a doubt, if there's a single tool that's going to help solve many of these issues, it's digital innovation in oil and gas. And so that's the purpose behind the book, is to fix this supply and demand imbalance as I see it.
Do you think the supply and demand imbalance started off because there was so many different heydays and boom in the oil and gas space, where you have $100 plus per barrel, where efficiency was less important than driving production? And now with the reduced cost and focus on renewables and other competing technologies, now they're forced to innovate where they weren't before?
I think there isn't any one single reason, frankly, as to why the industry lags. Here's a handful that I see. We have an education system that does not require, as part of the educational curriculum, that the engineers who are learning the disciplines necessary, that it's not requiring them to stay abreast of digital innovation. So we have to fix the educational system as a priority. Second, the value release from digital or these digital technologies is tainted by a legacy of ill-considered investments in computer automation and commercial systems and the like in oil and gas that has left a residue of negativity and skepticism about the power of these tools. We have to overcome that. And then we have a business that runs 24/7 that has to be kept absolutely safe and run reliably. And there's just no window to go in and, drill holes in things to kind of attach new sensor technology or add capability. So you have this industry that's, when you start to look at it systemically, it's like, well, it's no wonder it's a kind of a laggard in adopting digital change. Now, what's driving it today, though, to accelerate is the pandemic has shown the industry that it can change, and it can change quickly. A good example would be, the use of artificial intelligence tools to do things like predict. Today, if imagine a pipeline scenario where you're running a pipeline, and there's so much data coming at you that you cannot predict how the pipeline is going to perform precisely even just a few hours ahead. And there's so many variables at play that it beggars the human's capability. We're just not wired to process data at the pace and complexity of of these complex assets. And so by the adoption of these kinds of smart tools in the control room, the tools can start to look at all of the data coming at the pipeline and say, hey, you know what, 4 hours from now, you're going to have a problem. Weather systems changing, or the composition of the product flowing through the pipeline, or the price of energy is going to go up. And if your goal is to achieve a certain target, the machine can now predict you're not going to make your target. Power of these tools is beyond understanding, beyond comprehension as to how much capability there really is for us to transform the business.
Yeah, I like thinking of AI in that capacity. Is that what you're doing is bringing more information and better information to the decision makers themselves. Like there's always been this fear, uncertainty, and doubt around, is AI going to replace jobs? And I think it only enhances jobs. It makes you go faster and more reliable.
Yeah, no, I think that's quite true. I think the industry is coming to the realization that artificial intelligence tools, for the moment, it might change in the future, but for the moment, these tools are an assistant to an existing worker on a job. And as opposed to they are going to become the job, like the job fulfiller. So we have, the industry has to change its narrative to help people see that, because it's very easy to look at a robot and go, oh, they're going to replace me. And but the reality is I do not see that in any short time frame.
I would agree. I've heard it compared to being like AI is a bicycle for your brain. Like humans can go faster on a bicycle, but they still make all the decisions. Whereas AI, it helps you make a better decision faster.
Yeah, it's a good example. An algorithm can tell you, should you shut this well in, right? That's math. It's a simple math. But should you shut the well in? It's a different question. Yeah. Because if you look at it in the macro sense from an oil company, sometimes it makes a lot of sense to run wells, even though they might be slightly uneconomic, because if you shut them down, the cost of bringing them back up may be too great, or maybe the reservoir will be damaged. An algorithm can't make that decision. So you're just going to have to require this balance. And that's why I think, like as you sketch out, this is going to be a bicycle for the brain, but it's not going to be the brain.
Who's the one that's actually driving the innovation? Who picks the off-the-shelf software? Who internally develops? And who's ultimately accountable for these innovations that are happening?
Well, the research shows quite clearly that innovation in oil and gas is predominantly driven by the suppliers of technology to the industry. It's not the producers themselves. The oil and gas producer, the company that owns the wells and access to the reservoir and produces the product, principally are not the prime innovators. The prime innovators are going to be the drilling companies, the fracking companies, the services that they purchase. And the reason for that, I believe, is that the technology for these services companies turns over quite quickly, every 2 or 3 years. I was on a call with a drilling company just yesterday, and the life cycle of some of their most valuable gear is measured in 2 or 3 years. So every 2 or 3 years, they're throwing that technology out and bringing in new technology. So they're on a treadmill to keep the capital flowing through and innovating because of the market demand. So that's where you find the bulk of the innovation.
And that makes sense in that it should make it difficult for staff who are required to make these decisions and ultimately acquire budget for them and then move it into the organization and implement it. They would be under heavy scrutiny for any change that they bring in. And of course, not every technology is as much of a slam dunk as the best ones. The worst ones are going to be much worse than the best ones.
Yeah.
Is that perhaps one of the reasons why there's a little bit of reluctance on demand, is because the stakes are pretty high when you make a bad decision there?
Yeah, there's absolutely, that's the case. I would characterize it in the industry is that it is an unforgiving industry for failure. And as a society, we are actually quite grateful for that. Like the last thing you want is engineers and professionals in the industry experimenting on things that, are toxic, poisonous, explosive, flammable, right?
Mm.
You want all that done to be done very carefully in a lab setting first. So we're actually quite grateful that the industry takes its time at introducing change.
To be prime targets for it, when we hear Amazon and Google and Tesla and all these other companies that are newer, fresher, innovative perhaps, and less constrained by what has historically been done. Uh, is oil and gas worried that those companies from an energy perspective are going to eat their lunch? And if so, who's acting on that?
Uh, yeah, are they concerned? I believe they are concerned in the sense that at the very, very tail end of the oil and gas supply chain, 50% of the barrel of oil, roughly, it's between 30 and 50, depending on where you are, goes into the transportation fuel sector. And of the transportation fuel sector, planes, trains, automobiles, some portion of that, some significant chunk of it is automobiles. And at some time, we're going to see a material shift away from gasoline-powered engines to electric engines. And there's a huge gap between the relationship that an oil and gas company has with its customers and what a power company has with its customers. I have a power relationship with a company that supplies me electricity, and I get a bill from them every month. I might not like the bill, still
Sure.
get it. I know where I live, but I don't think there's a single gasoline supplier in the world who knows my name or my address. Like it's all that's done through Visa. So the relationship with the end customer for their energy consumption is now suddenly on the table and up for grabs.
I wouldn't mind talking a little bit about the information and what I'll call an information problem in industry first, before I'd call it in oil and gas industry. Our data as Shiny Docs, as an organization who makes it a purpose of understanding data, showed that in around 2007, we massively eclipsed the ability for the content systems that are out there to manage, understand, and action the content that has been generated, especially now with media and drones recording data, video, everything else. We have hundreds of times the amount of information that would be manageable by those systems. How do you feel like that's affecting oil and gas, and what kind of problems does that present for them?
Well, I'm going to give you an interesting example, a live example. There is a startup in Calgary that is tackling a specific data problem in the industry. When you're drilling an oil well, the drilling cuttings, those are the bits of rock that the drill bit grinds away way down underground. Those all come to the surface. And traditionally, those get collected in what's called a tray. And then the geologist stares at the rock to try and decide whether or not there's presence of hydrocarbons. And that those cuttings get sent off to labs who then study them for radioactivity and the presence of other metals and how hard the rock is, et cetera, et cetera. And that's a 6 or 8 week sort of lab exercise. This company is taking high definition photographs as the cuttings come up off of the drilling onto the drilling table. And then they send those up to the cloud. And then using machine learning, they piece together this detailed image of what's actually underground based on what the cuttings are showing them. It's 1,000,000 times more data than you have out of a traditional drilling program. Not 10 times, not 100, not 1,000, 1,000,000 times more data. It's 2 terabytes of data per well. The amount of information is extraordinary coming off of this. The industry is not set up correctly to process 1,000,000 times more data overnight. Like that's stuff. So the volume, the complexity, the calculations, the algorithms are racing ahead at this crazy pace. And if anyone thinks, well, this is a problem our industry doesn't deal with, no. You're that's just, it's absolutely going to be a shift in thinking about data, how to organize it correctly, how to leverage it properly, how to use it, the algorithms, and it's all on the table for change today. Half jokingly, I was on a show earlier today, and I said that in light of the Colonial Pipeline disaster in the United States, I think ransomware is Russia's way of teaching Americans where their energy comes from. that's what they, you know, So we have a cyber problem we need to deal with. In the case of the BP Macondo disaster in the Gulf of Mexico many years ago, 2000 and I can't remember now how far back it was, 2008, 2007, when that disaster happened, it became imperative not to actually go, if you're a litigator and you wanted to uh, 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 build your case, it was your first priority to discredit all of the information systems associated with all of that data. Because if you could discredit the system, you didn't have to argue about the data. You could say, well, the system is flawed. So the key in the case of the oil companies is, okay, you don't have a flawed system. Have a very, very good gold standard system. That way, if you do get into some difficulty, you're going to force the litigation conversation at the bit level, not at the system level. And you have a much better litigation opportunity or chance of success if you can show that your systems were well run, and it's just one or two things went sideways versus no, the whole system is incorrect.
The thesis that we bring, and I love your comment on this, is that I do like the artificial intelligence to generate the data. There's obvious savings. I do like the idea of bringing in massively scalable search for these things. And the layer that we add is really the meta and omni understanding across those systems. And I'll give an example of Facebook knows a lot about you and people that live in your area or people that are like you, your interests and these types of things. So when an advertiser comes along and says, I'd like to identify every dog owner that lives in Calgary or whatever that group of demographic is, then the pet store can advertise to you or them or anybody else with very high efficacy.
Mhm.
We looked at that and said, that's the exact same problem with data, is that I don't want to necessarily be a better search engine. I don't even necessarily, even though we have AI and these types of things, I don't want to be in competition to try to have the best AI. That's not easy at this point. But to have that layer across all of it where you can have the meta understanding and be able to ask, okay, I'd like all the pressure tests for this particular pipe. I would like to find all of the engineering certifications that happen. Show me the work orders and then the upstream purchase orders. And to ask, it's the same kind of question as pet owners in a particular city, and then apply that type of technology so that you can ask bigger questions across bigger data sets. And it's no longer about, okay, move it into this old enterprise content management system or migrate it off a shared drive or whatever. The question is, just ask about your data and get the graph will give you that information back. What do you think oil and gas's readiness is for that type of technology, and how do you think it might be able to influence them if implemented properly?
Would be very ready for that kind of structured analysis engine. The industry sits on oceans and oceans of data, and it lacks that layer above. And the way you get at understanding in the industry is you pay for one-off studies or analysis to try and answer those questions, and someone or a group has to go and collect the data from all of the places below, and then figure out the analytics to drive the conclusions that you're seeking. And that's manual. It's manual and it's slow and it's costly. And frequently the industry will do the same analysis over and over and over again because it forgot or it lost or didn't understand, or the people who are doing the original analysis are long gone. So the industry pays over and over again for some of the same analysis. And so is there an appetite for that? Yes, there absolutely would be. And the key here, in my sense, is that if you said to this industry, you need to build this big infrastructure first to get to that answer, the industry would say, no, we're not doing that. If you can get to that answer without having to invest hugely to move all the data into a single place, data lake or some other structure, but you can get at it to where it's located, then you've got a much faster chance to succeed with the industry.